Hey everybody, it's Rick Uzzi. Welcome to Tech Tuesday. Today we're going to be talking a little bit more about Carrier Grade NAT. Stand by. Thanks again for joining us. Today I'm with Alexander Britkin from NFWare. Welcome, Alex.
Hi, Rick. Yeah. Thanks for having me here.
Again, we're going to be talking about CGNAT today. Remember that you can always chat with us. Let us know that you're online, or if you have any questions, feel free to do that either during the broadcast or after if you're watching this recorded on YouTube. If at the end you like this video, please click the thumbs up and like it. You can always subscribe to our channel to find out whenever we're going to be live, and then also click the bell to get notifications. So again, thanks for joining us. So Alex, you are on the West Coast. I'm on the East Coast, so we're having a little conversation here across the country about Carrier Grade NAT. And you're with NFWare. You're the CEO of NFWare. Why don't you tell us a little bit about your company?
Yeah, sure. We started this company 5 years ago with an idea to bring more software and virtualization to carriers' networks. And our key innovation is how to make software work really fast, as fast as hardware. And because CGNAT is a throughput-intensive network application, we provide it basically as a virtual machine, which can run on top of any standard server with the Intel or ARM CPU, which was kind of not possible before, because before that, this kind of they were working on top of legacy hardware with the FPGA or ASIC chipsets. So currently, that's not our only application, not our only product, but this one is currently deployed in multiple carriers worldwide, and the customers are quite happy with it because, first of all, it's very reliable, as it should be, but then it's because it's software, it's also more flexible, scalable, and it's quite cost efficient, and I will be happy to tell more about how it works during today's broadcast.
Okay, so I guess an advantage there is that somebody can have just kind of standard hardware, like x86 hardware, or even a virtualized environment, and you don't need this proprietary software to go ahead and run that, right? You can just run it on standard out-of-the-box hardware. That's, I guess, the cost savings as well as less complexity and maybe better scalability. Is that right?
Yeah, absolutely. So this kind of hardware you can buy in the shop nearby. You don't have to wait until it's shipped from Taiwan or wherever they are being manufactured. And on the same hardware, you actually run other applications, so you can save on hardware a lot. And I think 10x at least.
Mm-hmm. Cool. So you've got some slides that we wanted to bring up here. So let me go ahead and get those started right now. Take a look at it. So, all right, so what we're looking at right now on the screen is NAT44, which I believe would be if somebody is wanting to do a IPv4 conservation kind of thing, where they're on an IPv4 network and they maybe need to maintain that for a while. Is that correct?
Yeah, absolutely.
All right, so why don't you explain here what we're looking at in this diagram?
So in this diagram, we see two networks. The first is the carrier's IPv4 access network. This is kind of a private network. Sometimes IPv4 and this network, they're called gray. And we see a public IPv4 internet on the right side. Mm-hmm. So the idea of NAT is that it allows you to share one public IP address from the right side between several subscribers on the left side. Mm-hmm. And this application, it maintains the state. So internally, it has the database which maintains which customer has which public IP and ports and etc., which we will describe a little bit later. Mm-hmm. And when a subscriber goes to internet, he or his CPE device is being assigned with the internal IPv4 address, which is then mapped by CGNAT to a public IPv4 address, which can be shared between several subscribers, so some other guys can have this IPv4 public IPv4 address too. And our recommendation would be to have no more than 128 subscribers behind the same public IP address.
That's quite a lot. So again, that's just, I think that kind of shows you the power of this. If somebody's short on IPv4 addresses, what you're saying is that before, where they might allocate, or they usually would allocate at least one address for every subscriber, now they can have one address for up to 128. Wow. That's amazing.
Yeah,
so on the next slide, we're looking at, I've got a cloud with IPv6 and IPv4. Would this be NAT64?
Yeah, that is NAT64. That's just one of the options how you can migrate to IPv6 network, which eventually, I hope, we will see during our lifetime. So here it works in kind of a similar way in terms of statefulness and sessions. However, when a subscriber in the internal network, he wants to go to IPv6 resource in the public internet, he goes directly, usually. But still, there are a lot of resources in public internet which supports only IPv4. So for that case, a customer operator may need the NAT64, which translates from IPv6 to IPv4, all the requests. There is also a DNS64 server which allows to translate the requests for domain names, which is also being requested by the subscriber.
So, yeah,
as you can see.
So
yeah.
for the service provider, for the ISP that's providing service today, it seems like the motivation for them, at least right now, would be, do they have enough IPv4 addresses? Because right now, their customers, a lot of websites, I guess, are moving to IPv6, but they have to support both IPv4 and IPv6. Is that correct? Right.
Yeah.
So they're not feeling
correct.
any pressure from that move to IPv6 on the content side. So I guess where the pressure would come for them would be being able to support, continue to support IPv4 content after they run out of addresses. Is that right? Okay.
Yeah. Well, IPv4 content should be supported and will be supported for a long time.
Right, but they need, for their customers to get to it, they have to have either a CGNAT solution or enough addresses to be able to do that. Yeah, okay.
Yeah.
All right, so let's see what we've got here. So now we're looking at the assignment of IPs. What would this relate to?
So I just wanted to point out that when a subscriber accesses the public internet, it's important, well, we advise it to enable a setting which allows to have the same public IP address assigned to him for all his requests. Because, well, in NAT, actually, for each new request, you can have another public IP address. Yeah, but we don't want that. We do not advise that. So it's better to have this regime for a customer to have the same IP address for all his requests. Well, I can tell that if that's not enabled today, then a lot of applications may be broken. First of all, gaming, because the gaming service, the gaming application on public internet, it expects that the gamer has the same IP address when it plays. So that's not one. On the right side, it's interesting. What about if an external application wants to access subscriber in the internal network? So how it works? Well, we have multiple options for that. The first one is that we allow any request from public internet to subscriber. They may access it through his public IP address, which he obtained through CGNAT, and then we forward it to the device. But for security reasons, operators, they may choose not to allow those requests, and in this case, only those services from those IP addresses and maybe ports, which is even more strict, will be allowed to access the subscriber. So that's more security setting. And here I also wanted to pay your attention that CGNAT does not only solve the IPv4 problem and allows to migrate to IPv6, but also because it's placed on kind of the edge of the network. It's a good place to have some security and to block, some attacks and, malicious packets and which we also provide.
So kind of just almost by default of having it in place like that, you can get some of that protection?
Yeah, well, by default, if we see the packet which is just wrong, we will protect against that packet. But there are more advanced techniques to protect the internal network of operator. And CGNAT is a good place. At least this place of the network is a good place to have this protection because it's on the edge.
So I know one of the objections that people have sometimes when they're thinking about CGNAT, and this may be something that they've maybe read online, would be that there are some maybe some applications that might break because of having NAT in the middle. So there are ways that you guys get around that, right?
Yeah, so for that, in CGNAT, there is application layer gateways modules. There are multiple of them, each for a protocol. And as you can see on this picture, there are like DNS, FTP, SAP, and others. Those are most important. There could be more, of course. So the ALG and how applications would work if we put the NAT in the network is a very hot topic. You can, it raises a lot of concern, and ALG is the way to overcome that. So what ALG is? ALG is the model which allows us to go inside of the payload of the packet. So usually NAT, it works on the IP packet level, and then changes the IP address and ports on the header of the packet. Now ALG allows to go inside the payload and see, okay, so this is the FTP packet, there is a IP address and there are ports, and there are other things. And we can also change those in ALG. And we should change because, in order not to break the application from normal behavior. However, good news is that more and more applications today, they are being developed and they support the NAT, working with NAT, so they can work through NAT without any issues and without actually any ALGs. And the trend we see that less and less ALGs are being actually enabled in the network because applications, they just work without them.
Yeah, so you've got it covered if need be through these ALGs, but I guess the providers of these protocols and applications realize that things are moving to NAT, or a lot of networks are. Is that right? Yeah. Okay.
Yeah.
And another thing that we'll hear sometimes from people that are considering CGNAT would be, what happens if I get a call from the sheriff and he wants to know who is using a particular IP address at a particular time? They had a certain way of doing that when everybody had a public address, but now they're like, well, what do I do if it's, as you mentioned, 128 people maybe sharing the same IP address? How do you get around that?
Yeah, so what makes CGNAT different from just standard NAT is first is usually LG, and then also this logging capability to log every session creation or deletion from subscribers, and for the reason you just explained. So here you can see that we have two records to create a session. You can see that it was December 28th at 4 o'clock, and then A, which is session created, then 17 is the protocol number. From internal IP and port to external, it was mapped to external IP and port starting from 203 to the destination. And this destination could be, I don't know, some illegal content. And by that destination, you can track the guy. And the direction was outside. And then the second record is that this session was deleted, because we need to make sure that that guy used that session and then he stopped using that session, because that IP and port can be assigned to other people in the network. And that's a very important thing to have. And we in the product, those log records have been generated and sent to a log server. And then on the log server, you have a database where you can search and then find out who was who during that point of time accessing that particular resource on the internet. However, there is another way we can do that, and it's called port block allocation, where we lock every session creation. At the very beginning, we assign a number of ports to subscriber, let's say 2,000 ports. And then we just have a record that, okay, this guy at this point of time, he got this block of ports, and then we don't lock any session creation or deletion during that time for that port block, because, well, we assume that the guy uses ports from that block. This is option number 2. And option number 3, where you don't need any logging at all, is a deterministic NAT, where by algorithm and you can understand who had which public IP address at which point of time.
Okay. And what are you seeing now in the area of Carrier Grade NAT as far as demand from service providers? Because we've been out of IPv4 for quite a while, so options are that people can buy more or look at Carrier Grade NAT as an option. Are you starting to see, as the prices go up on IPv4 addresses, more people asking about it? What are the trends as you see them?
So more and more operators, they choose CGNAT as a way to solve the IPv4 depletion problem. And there are a number of operators which were visionary enough to deploy IPv6 from early days, both wireless and wireline. But the majority of operators, they are looking for some kind of solution, not to buy IP addresses, but to solve that in long term. And the most of the demand, of course, for this kind of solution, it comes from wireless operators, because the number of devices which they have is enormous. Mm-hmm. And we believe that with the IoT explosion, where by predictions there should be 30 to 50 billion new devices, mm-hmm. the problem will be even bigger. Mm-hmm. So, we believe that's the right way to solve that.
And I guess I mentioned this last week, just when I was talking about CGNAT, in that people are, unless they have enough IPv4 addresses to take them until the end of IPv4, which is, I'm assuming, going to be a really long time, they're probably going to need Carrier Grade NAT at some point. Would that be a fair statement?
Yeah. Yeah. Mm-hmm. Well, maybe not NAT44, maybe 64, maybe other like a DSLite or other options of NAT, but yeah, mm-hmm. they should have it at some point of time.
Yeah. Okay. All right. Well, I appreciate you taking the time to be with us here today, Alex. That was very informative on the technical side. Let me remind everybody that you can subscribe to our channel by clicking the subscribe button, and Zecorum does we're a partner of NFWare, so if you are interested in Carrier Grade NAT using NFWare's solution, you can contact us. You can see there on the screen, zecorum.com/CGNAT. You can get more information about CGNAT on that page. And again, what we work with NFWare in that you don't need to have, it's a software solution, you don't need to have the expertise to be able to install that on a server or in a virtual environment. That's where we can come in to help configure that for you and help you get it set up where that can be managed. So we found it to be a great solution ourselves. So Alex, thanks so much again for joining us.
Thanks for inviting, Rick, and have a great day, everyone.
Thanks. You have a great week, and everybody else, I hope you have a great day, and be sure to join us next week when we are discussing another topic. We'll see you then. Bye.